Okay, this is more on two-way tables. This is page 81 of the note spiral. Um, Leah is flying from Boston to Denver with a connection in Chicago. The probability her first flight leaves on time is 0.15. If the flight is on time, the probability that her luggage will make this connecting flight in Chicago is 0.95. But if the flight is delayed, the probability the luggage will not make it is 0.65. Now, I realize the table is filled out, but I'm going to go back over it with you here. So I'm going to go ahead and circle the numbers. Those are the three numbers that were given, and I need to determine which one of those is associated with only one variable. Well, when I read the probability her flight leaves on time, so this 0.15 is based on flight on time, and this looks like it's associated with only one variable. And it looks like it's associated with flight on time, all right, whether the flight is on time or not. But I still want to check the others just to make sure. The probability that her luggage will make if the flight is on time, so there's a condition here. If the flight is on time, that's tied to the 0.095, and her luggage is also tied to it. So this is tied to two variables, the flight and the luggage, okay? And then we have if the flight, so again, this 0.65 is tied to flight. It's also tied to luggage, so it's also tied to two variables. So we've correctly identified the one with one variable as 0.15. Anytime, once you have determined that variable, always put it in this part of the table every single time. That's okay. So every time that goes there, and that was associated with flight on time, so FO flight on time. The other would be flight delayed. The other variable we talked about was luggage, so her luggage makes it or her luggage is delayed. All right, so what do I do once I've established that I've found the 0.15? Well, I'm going to write 0.15 here, and then I'm also going to write it right here, 0.15, or try to write it. All right, that's supposed to say 0.15. I'm going to scratch that out, 0.15, okay? 1 minus 0.15 is 0.85. And once I've identified that 0.85, I can go ahead and bring it up as well. So this is 0.85. All right, now, if the flight is on time, so we're looking at flight on time, we're only looking at the flight on time column, the probability her luggage will make it. Oh, luggage with her is in this case, 0.95. And if I multiply those two, I'm going to get this value. 1 minus 0.95 is 0.05. This times this will give me that. So that's where that value came from. Now we need to look at the 0.65. If the flight is delayed, so now we're looking at the flight delayed column, the flight says flight delayed, so that's what tells us where we're looking. The probability that our luggage will make it, so we're also looking at luggage make it and flight delayed, is 0.65. So this times this will give me this. 1 minus that is 0.35. This times this will give me that. All right, please remember you can check your table. This plus this will equal this. This plus this will equal this. And of course, going horizontal, that plus that equals the total. And that's where the values come from and gives you a really good check. All right, so it asks us to make a tree diagram. Well, I'm not a big fan of tree diagrams. However, this is the way some people learn, and so consequently, I'm going to go ahead and make one. I'm not ever going to grade a table. I'm not going to grade the tree diagram. I just need to see your work as to how you got it. And for a lot of people, the tree diagram is the way to go. So here we go. So we identified the singular variable or the singular number that's associated with one variable, which is 0.15. So that's where we actually start with the tree diagram. So starting with the tree diagram, there's a 0.15 chance And that 0.15 is for flight being on time. And I'm just going to abbreviate that flight on time. Then we have a 0.85 of what? Well, the 0.85 is associated with being the flight delayed. So there's an 85% chance that the flight is delayed and a 15% chance that the flight is on time. If the flight is on time, and now we've dealt with flight time, now we need to deal with luggage. If the flight is on time, there's a 0.95 chance that the luggage on time. All right, so now we're looking at luggage on time, and that means there's a 5% chance, that the luggage is delayed. All right, so with those two numbers, this times this, 0.15 times the 0.95, and that equals 0.1425. Now I'm going to tell you what that represents. That is the intersection of intersection of flight on time and luggage on time. So flight on time intersect luggage on time. Okay. Here, multiplying what we have 0.15 times 0.05, and that equals 0.0075. And this is the flight's on time and the luggage is delayed. Okay, got to your destination on time, but you didn't have your luggage. The next one. Hope I left myself enough room. All right, so the next one, we have an 85% chance the flight is on time. 85% chance that the flight is delayed, and we need to look at the luggage. All right, well, it said if it's delayed, there's a 65% chance the luggage is on time. So we're back to luggage on time. So we multiply those, 0.85 times 0.65, and we find out that 55.5525, 55% of the passengers, their flight's delayed, but their luggage makes it with us. And this is the majority in this case. So flight delayed and the luggage is on time. All right. Then we have the other category, which are the ones that probably are messed over the worst, because now their luggage is delayed, and we've already said this is the flight delayed and their luggage is delayed. And in that group, we have 0.85, because there's an 85% chance that their flight is delayed, a 35% chance that if the flight's delayed, the luggage is delayed. When we multiply those, we find out that almost 30%, 0.2975, we find out the flight's delayed and the luggage is delayed. All right, and if I've done all of this correctly, these four probabilities will sum to one whole, okay? All right, so once again, you can either use the table. I personally like the table. It's my way of thinking. It's a nice organizational tool for me. I have a lot of students who prefer this. About a good third of my students who prefer the tree diagram. Both of them will work. Both are more than adequate for doing these types of problems. My primary purpose, the reason I'm not a tree diagram is I don't write neatly, and I make mistakes because my drawing is poor. Other than that, the tree diagram is great. All right. Thank you.